Welcome to the DIY Honda Garage channel. In this presentation, we will explore DTC P0335, which indicates a CKP Sensor No Signal error specifically for the Honda CRV models from 2011 to 2016. The crankshaft position, CKP sensor, is a critical component within the vehicle's engine management system. It is responsible for monitoring the position and rotational speed of the crankshaft, which is essential for precise engine timing and overall performance. When this sensor fails to transmit a signal, it can lead to stalling, rough idling, or an inability to start the engine. The DTC P0335 can illuminate on the vehicle's diagnostic screen, prompting a troubleshooting investigation. Using appropriate diagnostic tools, like the Honda Diagnostic System, HDS, will allow you to effectively diagnose and resolve this issue, ensuring the vehicle returns to optimal working condition. DTC P0335, identified as CKP Sensor No Signal, pertains to the crankshaft position sensor, CKP. This sensor plays a crucial role in the vehicle's engine management system by detecting the position and speed of the crankshaft. Its primary function is to ensure that the engine timing is achieved accurately, allowing the vehicle to perform efficiently. The CKP sensor is usually located near the crankshaft, an area susceptible to wear and tear due to engine vibrations and heat. If the sensor does not transmit a signal, the engine control module, ECM, cannot optimize fuel injection and ignition timing, leading to performance issues. For the Honda CRV models from 2011 to 2016, this error can lead to symptoms such as stalling or difficulty starting the vehicle. When diagnosing DTC P0335, several potential culprits may be responsible for the error. One significant cause could be a disconnected crankshaft position, CKP sensor, which would obviously prevent signal transmission. Another possibility is an open circuit in the harness that connects the CKP sensor to the engine control module, ECM. This could result in a break in the electrical flow, rendering the sensor useless for signaling its readings. Additionally, a short in the wiring could lead to erratic performance or complete signal failure. Lastly, it is essential to consider the CKP sensor itself, which may be faulty and require replacement. Accurate troubleshooting is critical to identifying the true cause and restoring proper engine function. Drivers may experience a range of symptoms associated with DTC P0335, indicating issues stemming from a faulty crankshaft position, CKP sensor. A common symptom is the inability to start the engine, as the ECM lacks essential data for ignition timing. If the engine does start, it might exhibit rough idling, which may lead to an unstable engine performance where RPMs fluctuate unexpectedly. Additionally, there may be situations where the engine stalls during operation, posing safety risks if it happens while driving. Furthermore, the check engine light will illuminate on the dashboard, alerting drivers to check for diagnostic trouble codes. These symptoms make it critical to address DTC P0335 promptly for safety and performance. The first troubleshooting step for DTC P0335 involves several key actions that allow technicians to confirm the existence of the error. Start by turning the ignition switch to the on position, which is indicated as Step 2. Next, you'll need to use the Honda Diagnostic System, HDS, to clear the diagnostic trouble codes to begin with a clean slate. After clearing the DTC, proceed to start the engine, which will help in determining if the issue persists. Finally, check for any pending or confirmed DTCs again using the HDS. If DTC P0335 reappears, it confirms the issue. If not, the problem may be intermittent, and you should examine connections at the CKP sensor and the powertrain control module, PCM, for any loose terminals. Moving on to the second step in troubleshooting DTC P0335. You'll commence by switching the ignition off and turning it to the lock position, designated as Step 0. This is a crucial safety measure to avoid accidental electrical discharge. Next, disconnect the CKP sensor's 3P connector, as this will help isolate the sensor for further testing. After disconnecting the sensor, turn the ignition to On, once more to power the system without starting the engine. At this point, you'll measure the voltage across specific test points, specifically between the yellow-black wire at the CKP sensor connector and a body ground. If you detect battery voltage, it confirms that the IGP crank Phi main RLY out wire is functioning properly and allows you to proceed to the next step. Step 3 requires you to assess the voltage of the crank P line to identify potential issues further. Ensure the ignition is still in the on second position. Just like in the previous steps, keep the CKP sensor's 3P connector disconnected. At this point, measure the voltage between the CKP sensor 3P connector number 3, which is the blue wire, and a body ground. You are looking to confirm if there is approximately 5.0 volts present. If the voltage is present, it indicates that the connections are likely intact and directs you to the next troubleshooting step. If this condition does not hold, it may point to further issues that need addressing either in the sensor or associated wiring. In Step 4, you will perform a voltage check for the LG2 crank LG2 lines to further troubleshoot the CKP sensor's connectivity. Ensure the CKP sensor's 3P connector remains disconnected to isolate the wiring. Measure the voltage between the yellow BLK wire at the CKP sensor connector and the BRN yellow wire on the same connector. This test is vital as it confirms the continuity and functionality of the LG2 line. If you confirm the presence of battery voltage, it is an indication that the wires are intact and the sensor likely needs replacement. Conversely, if there is a lack of voltage, you'll need to investigate and repair an open in the wiring between the CKP sensor and ground point G101. Step 5 involves a thorough check for shorted wiring regarding the crank P line. Begin by switching the ignition to the lock position for safety. Utilize the HDS to jump the SCS line, and then proceed to disconnect the PCM connector C, which contains vital information for the crankshaft position sensor. You will need to check for continuity between the blue wire at the PCM connector, number 42, and a body ground. This step is crucial, as gaining continuity indicates that there is a short present in the wiring between the PCM and the CKP sensor. If continuity is verified, repair the short, ensuring secure connections, and then move on to the last steps of troubleshooting. The sixth step centers on ensuring that the crank P wiring is intact. Connect terminals A and B using a jumper wire, with terminal A being the CKP sensor's number 3, the blue wire, and terminal B being connected to the body ground. This is to create a pathway that allows you to check for continuity between the CKP connector and the PCM connector number 42. You will again utilize the IG lock 0 position. When you measure for continuity, the expectation is to find a complete circuit that signifies that there are no breaks in the wiring. If continuity passes the test, it may indicate that the PCM should be updated for software or replaced if issues persist. If there is no continuity, repair any open wiring found to ensure proper signal transmission. To verify repairs related to DTC P0335, begin by turning the ignition to the lock position and reconnecting all relevant connectors associated with the CKP sensor and PCM. Once everything is reconnected, turn the ignition to the on-to position once again to power on the systems. Use the HDS to reset the PCM so that it can recalibrate itself with the newly reinstated components. Additionally, it's important to perform the CKP pattern clear or learn procedure, which ensures that the PCM can accurately determine the crankshaft position post-repair. Following these steps, you must check for any pending or confirmed DTCs. If DTC P0335 is still present, further investigation is required to ensure everything is functioning as intended. Preventive maintenance is crucial in avoiding DTC P0335 in the future. One recommended practice is to regularly inspect the wiring associated with the CKP sensor, as well as its connections to the PCM. This will help identify any wear or damage before they lead to a sensor failure. Updating the PCM software regularly can also keep the engine management system operating smoothly, minimizing the chances of errors occurring. Furthermore, maintaining a clean engine bay prevents debris and buildup, which can affect sensor performance. By integrating these maintenance activities into routine checks, you can enhance the longevity and reliability of your vehicle's engine system. In conclusion, DTC P0335 signifies a crucial failure in the CKP sensor. Understanding the role of the CKP sensor in engine performance can not only help diagnose this issue, but also shape preventive measures to avoid similar occurrences in the future. Following detailed troubleshooting steps provided ensures that no critical areas are overlooked. Each step plays a role in isolating the problem, whether it's a disconnected sensor, faulty wiring, or a malfunctioning sensor itself. Ultimately, performing preventive maintenance and regular checks on wiring and connections will ensure the vehicle operates efficiently and reduces the chances of triggering DTC P0335 repeatedly. By addressing such errors proactively, you contribute to the overall health and performance of your Honda CRV. Please like and subscribe to the channel. See you next time.